Okay, here are your notes for section 3.4, finding an equation of a line. Your journal choice is right here for your pleasure. Objective and what's the point? Today we're going to talk about all sorts of writing equations of lines. We're going to be introduced to a new formula and piecewise functions. It's a bit of a complex section, so hang in there. This is super important because you have to model situations all the time, and we do that by writing equations of lines, and we need to familiarize ourselves with different ways of writing these. Okay, recall. Given a line, there is exactly one line through a given point that is parallel to that given line. Go back to your geometry days. We have a line, here it is, and let's say I have a point right here. How many different ways could I draw a line through this point that would be parallel to the one that I started with? And then you're right, there's just one, okay? Because it would have to be this way. The reason it would be just one is because that slope, that slantness has to be the same, and the only way we could go is through this point. Because of that, because the slopes of parallel lines are the same, and because of this theorem from geometry, we now know that there are only two things necessary when you write an equation of a line. You need a point that's on the line, and you need the slope of that line. Now, when I teach my lower level students what you need to write an equation of a line, I say you need the slope and the y-intercept. And you guys know why I tell them that, because y equals mx plus b. That's not entirely true. That is a slope, and the point, it's just a special point, and it makes it easier for them. But today we're going to be any old point. It does not have to be the y-intercept. So it'll make things a little bit different. Because of the new formula we're going to be using, there are a lot of ways to express these lines. You might have different answers in the back of the book or your neighbor, so you don't need to feel uncomfortable about that. Okay, stuff you need to know. This is a point-slope theorem, and I'll be 100% honest, when I was a student in Algebra 2, I rebelled. I didn't want to know this formula because I was a superstar at y equals mx plus b. I was very good at using it. I could do everything I wanted with it, and that is true. You can do almost everything you would like with y equals mx plus b. This formula is a little bit quicker, and I think one of the reasons I didn't want to use it was because I didn't want to memorize it. But when you think about where this comes from, and nobody has told me that when I was a student, or the definition of slope, where this is coming from, I think you'll like it. Okay, here is the formula. Y minus y1 equals mx minus x1. You plug your slope in here, and you plug in your points into x and y. Okay? x1, y1, excuse me. X and y have to be in your answer because an equation of a line has x and y. This is coming from this guy, and everybody knows this, rise over run. Okay, if I multiply both sides by x2 minus x1, that's where this point slope formula is coming from. I now have y2 minus y1 equals, there's my slope, m, x2 minus x1. Except they don't have the 2's. They just left those out. So that's where the formula came from. Now, you can write it this way. Y equals m times x minus x1 plus y1. They just added y1 to both sides. Why would you ever want to do that? Well, if you wanted to type it in your graphing calculator, you have to have y by itself. Okay. Again, you can use y equals mx plus b. This is a little quicker. You would get to the mx plus b if you distribute your slope and then combine all your like terms, and you'll end up with that slope-intercept formula. Okay, let's practice with it. And of course, we're going to use really nasty points. We're going to find a line that goes through these 2 points, 1/3, 2/5, and 7/3, 9/10. Okay? I told you there are 2 things you need. You need a point, and you need a slope. Well, great, Bruno. You said they gave me 2 points. They didn't even tell me the slope. Lucky for me that you guys can all find the slope by that happy formula. y2 minus y1 over x2 minus x1. So now I have 9/10 minus 2/5 all over 7/3 minus 1/3. And that gives me 5/10 or 1/2 divided by 7/3 minus 1/3. That's 6/3, which is 2. Don't ever leave something like this. This is kind of a no-no in math. It's not very mathematically polite. We'll go ahead and change that. You could use your calculator or you could use your fraction division. This is 1/4. So my slope is 1/4. Now I have the slope, but I have 2 points. So which one do I use? You get to choose. Okay? If 0 was a part of one of these points, I would definitely pick it. Pick the one that speaks to you, the one that looks easiest. These both look kind of equally as complicated, so I will use the first one. I assure you, if you use the second point, you would get the same answer. It will look very different than mine, but if you got y by itself or you graphed it in your graphing calculator, it is the equivalent formula for the line. Okay? So let's use our point slope formula. Y minus y1 equals mx minus x1. Plug in our slope here and plug in our point. x1, y1. I now have y minus 2/5 equals 1/4 x minus 7/3. You can leave it this way. It is fine. If you wanted to clean it up, you could do that also. What do I mean by clean it up? Well, you could add 2/5. You could distribute the 1/4, but we're not going to do all that. But you totally could do that if you'd like. Okay. More practice. An approximate conversion from degrees Celsius on a Celsius scale to degrees Fahrenheit on the Fahrenheit scale is F is approximately 2C plus 32. We are going to use these facts that 32 degrees Fahrenheit is 0 degrees Celsius and 100 degrees Celsius is 212 degrees Fahrenheit, and that the two scales are related linearly to write a more accurate formula. Okay, so we are going to relate F and C. I'm going to actually do C comma F. The reason I'm doing that is because this is on the left hand side of the equation, so it just reminds me of y equals mx plus b, but it didn't tell you, so technically it wouldn't matter. 32, 0 I can write as an ordered pair. 100, 212 I can write as an ordered pair. I can now do what we did before. I have 2 points. I do need the slope, so I'll go ahead and use my y2 minus y1 over x2 minus x1. Some of you might think this is overkill that I'm writing this formula every time. 212 minus 32 all over 100 minus 0. That works out nice. So that's 100. 212 minus 32. 180 over 100. Drop your zeros. 18 over 10, that's 1.8. So my slope is 1.8. Pick your favorite point. Again, if 0's in there, I'm going to pick it. It makes things nicer when they plug in. I'm using point slope formula since I have a point and a slope. It makes things a little easier. Y minus 32 equals m, 1.8. X minus 0, or just x. Look how quick this gets into slope-intercept form. Y equals 1.8x. All I do is add the 32 to both sides. Plus 32. And it's more accurate than this 2. I do want to show you real quick how I could use y equals mx plus b to figure this out. It would have started the same way. You would have plugged in the 1.8 and then you pick your favorite point. Again, I probably would have picked this one, and you plug this then in for x and y. So I would have 32 equals, our slope was 1.8, x was 0 plus b. 32 equals 0 plus b. Oh, look, b is 32. Well, b is my y-intercept. Now I know my slope and my y-intercept. Y equals 1.8x plus 32. It does work every time. You're just plugging in for x and y instead of x1 and y1. Okay, one more. Find an equation for the line through this point and parallel to this line. Okay, I need a point and a slope. Goody goody gumdrops. I have a point. Do I have a slope? No, I have a line, but it says it's parallel to this line. I know that parallel lines have the same slope, so the slope will be 4/7. So I have a slope and I have a point, which is 5, 3. I can use point slope formula. Y minus y1 equals m x minus x1. Y minus 3 equals 4/7 times x minus 5. It doesn't say it had to be slope-intercept form, so I'm going to go ahead and leave it like this. Good enough in point-slope form. All right, now these are the doozies, piecewise functions. Kids always hate piecewise functions because they're lazy and they take a long time, okay? You're going to get the point of this as I go. I'm probably going to stop halfway through this because you're going to get super bored. A function that is linear is a piecewise function, but it does have a constant rate of change. We're going to have like bits and pieces, and hence the word piecewise. It will be the union of several line segments, and we have seen one of these before, and we're going to look at it in a second. And what we do is that we're going to write each little piece of the lines equation, and then we'll have to restrict the domain on that piece. As we do the example, it'll make more sense to you. This will, I think, be on the test, and usually kids do struggle on it, so hang in there. We'll figure it out. Do you remember Frankfurter and I don't remember, Chuck Rose, that was his name, when they went on their picnic? This is their graph, and this is a piecewise graph. It meets all those requirements we talked about. It is the union of several line segments. It doesn't have a constant rate of change because like this is flatter and this is steeper. Okay, so we're going to write the equation of this, and it's going to have lots of pieces. You can tell how many pieces it has by how many segments there are. So there's 1, here's 2, 3, 4, 5, 6. This is a 6-piece piecewise function. I'm not going to do it all because it will be boring. But we are going to go through this here. Let's see if okay, I don't have a lot of space here. Here's what you need to do. You need to start with your first piece. So we don't have y here, we have distance. So it's going to be d equals, and then we do the gigantic forehead, nose, and chin. I made it gigantic because there needs to be 6 pieces. We're not going to finish it all like I said though, but let's look here. This is the first equation I want to write. Go with the endpoints or points you can find easily. I have 0, 0 is part of this one, and it looks like 34 is part of this one. So now I need to find the slope because I need a point and a slope, la la la. We've done this a lot. M equals y2 minus y1, 4 over 30, which is 2/15. I am saving some space on work here. If you have any questions, make sure you write it down and I'll talk to you about them tomorrow. There's my slope. Pick my point. I'm picking this one. I have y minus y1 equals m, x minus x1, 0. Do you see why zeros are so nice? Y equals 2/5 x. That's the equation of this little piece of line. Okay? So I have d equals, except it shouldn't have been x. We should have been using t here. Alright? So I have d equals 2/5 t. Now, that is only for this little piece of line. Graph 2 here is going to have a different line. So we restrict it. We say for whenever it's from 0 to looks like 45. For 0 less than equal to t less than equal to 45. That only works from 0 to 45. Okay, the next piece of line. This one is easy. This is a special line. Okay, if you know what you're doing, you could have done the, say, oh, this is just going to be y equals something. It looks like y equals 6. And you would be right, okay? If you didn't catch on to it, you would have arose at that solution by using the same points here. It looks like 45, 6, and 66. y2 minus y1, so you're going to get a slope of 0. So it would have all worked out, okay? What you do here is 6. This is the only kind of tricky part. We say for what? It goes that way from 45 to 60. 45, though, was on this domain, so I'm going to put 45 here, but I'm not going to say less than equal to. I'm going to say less than t less than equal to 60. You do have the option, you could have put the equal sign there and not there. It's just confusing when people are looking to the equations of the graph and they don't know which formula to follow. It would have worked out the same. Technically, I'm not going to mark you off if you put an equal there, but you should just have things show up just once in the domain. Okay, we're just going to do one more example of the piece, and I think then you'll get the general idea, because like I said, this does take a really long time. Let's look at this third piece. You're going to get some ordered pairs here. I'm just trying to erase. I need a bigger eraser. Okay. Okay, I like, looks like 66, that was our first point. And 90, 12, how about that? Okay, so I have 12 minus 6 over 90 minus 60. 6 over 30, 1/5. Pick your favorite point. None of them are really speaking to me. I'll just use the first one. Y minus y1, so y minus 6 equals m. X minus x1, which is 60. Y minus 6 equals, you do have to distribute this because you do have to get y by itself here. 1/5 x minus 12. Add 6, add 6. Y equals 1/5 x minus 6. So the next piece is, and again we're talking about t, not x, 1/5 t minus 6. When does this work? For 90 to 1, oh, are you for real? Did I mess this up? Nobody told me. It's because I'm by myself in here. That was 120, guys. No, it wasn't. Oh, I did that right. Just kidding. False alarm. I was looking at this next piece. 90, 12, 66. Oh, we're all good. 4, we're talking about for 60. We're not going to include that because it was already included. 2, come on, get out of the way. 120. No, to 90. Just kidding. I keep wanting to say not 120 for some reason. That's horrible. Pretend that's good. Should say this. Okay, we can continue this 6 times. This one is going to be, I can go ahead and do the next one. That'll be 12 for, we're going from 90 to 120. And then I'm guessing it'll just be the opposite of what we had before, but I'm not going to finish it out. Okay? Alright, here on your homework tonight you can, oh, you're not doing homework tonight, so pretend that's not there. We'll talk about that tomorrow. And look, go in peace, get it? Puzzle pieces, be wise, ow, they're wise. Haha, that's funny. Good joke. Okay, see ya later.